as part of your work with ORE Catapult, you've been working with innovations in the field of AI and robotics. How do you see these technologies disrupting offshore wind in the short term, say the next 5 years?
So I think the application of robotics and autonomous systems at the moment are still really being explored by the offshore wind industry. So we're only really at the tip of the iceberg with this technology. So the disruption that we expect to see in the next 5 years is an uptake in the use of some of these robotic systems, perhaps with limited or kind of basic autonomy built in. So, for example, we're already seeing an introduction of drones being used for remote blade inspection. This type of technology can decrease the health and safety risks which are involved with inspecting a turbine blade, but also have some different cost benefits compared to traditional means. So we really see robotics really coming in and improving the way we can gather data about assets, making it the job for the current operations and maintenance market safer. So that's kind of in the short term. A lot of these technologies are what we would say remote inspection technologies. Their application is a bit limited on what they actually do, but it tends to be visual or sensory monitoring of these offshore assets, as opposed to actually physically doing some work to the turbine. So that's what we would expect to see over the next 5 years.
That's interesting. And how about in the longer term?
So in the longer term, what we're working on some of the early stage research that we're involved with is increased autonomy. So we don't expect this to come in the short term because the maintenance tasks of these robots are still being explored at the moment, and until they know what these tasks are and they're predictable and repeatable, that's when the increased automation can come in, where robots can undertake the task, decide what needs to be done, and do it all without or with minimal human input. So in the next 5 years, we expect to see probably an increase in automation. So robots making the decisions and doing more of the work, and the operator being able to stand back and do a bit less, or even not be at the scene at all. So that's the next phase. Is current technologies are quite reliant on human deployment or human operation. So we still need to get a crew out to the offshore wind farm. We deploy the drone or the ROV or whatever it may be by hand, and then operate it next to the device itself. What we're hoping to see in the longer future, so 5 years plus, is the ability to perhaps operate some of these systems beyond visual line of sight. So there are technical and legislative challenges with some of these technologies being able to do that. But that's what the aspiration is, because that's where really it reduces the risk and the cost massively to the offshore industry. Finally, the final thing we would expect to see kind of being brought in 5 years plus is the ability for these robotics to achieve physical tasks. So move beyond taking photos, taking imagery and taking sensory readings to actually physically carrying out maintenance and repair. So whether that might be fixing some wind turbine blade damage or perhaps even repairing welds subsea, we expect those type of more advanced maintenance interactions to happen in the longer term.
Oh, that's really interesting stuff. And thinking about some of the things that might slow that down, specifically, what are some of the commercial challenges that could really put a brake on mainstream deployment?
So a number of the common commercial challenges we come up with is around the understanding of the commercial market and landscape of offshore wind. It's quite a complex arena to be in, with all the developers, the owner-operators, the service providers. It's quite a complex landscape, and there's not a one-size-fits-all across the industry. So for these small-scale innovators, who are often SMEs or even from an academic environment, for them to develop their technologies in line with this landscape can be quite difficult for them because they don't have that exposure. So that's part of, I guess, what we do at the ORE Catapult, is to support these companies, educate where we can, or make introductions and de-risk the technology from both the technical but also commercial standpoint. The other commercial challenge I do see, and we're often asked the question, is how does this impact on job creation and skills? Really, the answer is that these technologies should be complementary to the job creation and skills market, in that we're seeing a massive growth in offshore wind at the moment, and subsequently we're seeing a growth in that services sector, so the operations and maintenance. But what we would like to see as robotics kind of come in more mainstream is that the skills are just kind of changing area. So we will, in my personal opinion, I don't think we will ever see a fully robotic operations and maintenance supply chain. There will always be a human element at some point. So we see that market and skills and jobs still growing, but perhaps a section of that, instead of growing for the offshore kind of technician base, we might see additional jobs coming into the UK in the area of kind of operating these robotics, maintenance and repair of those robotic systems, analysis of data and the data-driven aspects of robotics. So there's quite a wide range of jobs we see this kind of opening up into.
Yeah, Artemis is our new cable tracker technology. It's a bit of a first for SMD. We're really excited. It's a sort of step change in the technology for detecting cables underwater. It's got three main points to it. First of all, find it. So it's for locating cables much deeper than the current technologies can manage. Secondly, tracking it. So when we're doing the trenching process, we're able to track the cable, or during a survey as well. And finally, proving that you've actually buried the cable to the depth required by the client as well.
So how does it actually work?
So one of the most successful ways of finding cables is to put down a tone down the cable, but this system actually generates a tone underwater rather than having to get access to the cable ends. So it generates a specific frequency of electric field, which in turn generates a specific frequency of magnetic field, which is at 3000 hertz, and we tune all of our equipment into that exact frequency.
Okay, and what kind of organisations would benefit from this?
So there's two groups really. The owners of the cable are always worried about where their cables are, what kind of condition it's in, and obviously if it gets damaged in some kind of storm or incident, how they can go about finding it. This technology really helps them to find cables that currently are buried beyond the technology's limits. The second group are the contractors who are actually installing and doing cable repairs themselves. So this equipment's then fitted to their ROVs or their trenching systems and forms part of the visualization of where the cable is during that process.
And so just thinking about AI and robotics a bit deeper, why are those technologies so important?
Typically in the North Sea, when the oil and gas industry grew up in the 70s, we were working in relatively shallow water, and the way to get there was by putting divers in the water. But over the years, we've really been looking at trying to remove the person from the water, the diver, and we've replaced them with robots. And particularly when we go into deeper water as well, in different parts of the world, divers can only work to about 200, 250 metres. In some areas of the world, we're working down to 3 kilometres, 3,000 metres plus. So it's essential that we start introducing new technology to get to those places that it's rather difficult to get to. So robots and robotics is such an important part of the future for underwater technology.
Yeah, I see that. and where would you say the innovation is coming from in that space?
Innovation, we talk about these vehicles being able to go to the work site, but the real smart stuff is what they actually do when they get there. Things like sensors, like cameras, like laser technology to measure things, to see through sonar, for example, all these different technologies that can be bolted on to a vehicle that can take something to that particular area. So the really smart technology, for example, it might be inspecting something to make sure it's okay. We talk about in offshore wind using drone technology to go and have a look at the rotors. Well, it's the same. We want to send these drones underwater to go down and have a look to make sure perhaps where the cable has been laid, to have a look where the foundations are, because sometimes the seabed can move with the current, so we need to make sure that nothing's being undermined and everything's still intact. So it's a way of actually monitoring everything in its field of life, over the period. So operations and maintenance is a very important part of offshore wind. But also when we're installing things as well, we have to make sure that we're putting them in the right place. We've surveyed the seabed, we know exactly where things are going. So it's a very high-tech part of the industry, and often we forget about it because it's beneath the surface of the ocean and we don't really see that much. Yeah.
Too true.
Yeah.
I mean, this is a space where there's an awful lot of cross-sector collaboration traditionally. To what extent do you think oil and gas companies have successfully transitioned into sectors like offshore wind?
Yeah, we talk about oil and gas companies, but the companies, they're not oil and gas companies as such. They're companies that specialise in working underwater, whether it's underwater hydraulics or control systems. They've supported an oil and gas industry as that has matured. But as the other sectors have appeared, such as renewables, those technologies are not specific to oil and gas. They can be transferred around a number of different sectors. So we have seen some much more, let's say, opportunity for companies to work in, say, oil and gas, but also in the defence sector and the offshore renewables, particularly offshore wind. So companies really have, perhaps in the past 3 to 4 years, seen that growth in the offshore renewables. So when we talk about oil and gas companies, I think we talk about the supply chain that supported the oil and gas companies. The supply chain can diversify and take their specific experience and capability to other sectors quite readily. It's just dealing with different end users, perhaps.
Yeah, so XOCEAN is an ocean data company, and we use a marine robotics system known as an unmanned surface vessel to collect this data. The sort of data we're collecting are things like mapping the seabed, looking at subsea pipelines, looking at, say, cables and connections. The way an unmanned system works is that we have a control room on shore, we then have a satellite connection to the vessel, and the vessel is on its own. It's operating anywhere from a few kilometres to a few hundred kilometres offshore, and that is fully controlled by the team of people that are onshore. Advantages of collecting data this way: first of all, safety. So there's no humans offshore, so that removes a massive risk from the marine operation. The second thing is environment. So we can operate for 3 weeks continuously, 24 hours a day, but we only use around 9 litres of diesel per 24 hours. An example of that is a survey ship could use 9 tonnes of diesel, 1,000 times more fuel. And we also use a solar array, which gives us about 20% range extension through just using natural sunlight. And thirdly, and importantly, is we can deliver the data at a lower cost.
Wow, that's some pretty compelling benefits there. And so can you give me an example of some of the projects you've worked on?
Yeah, we've completed a number of projects across a number of different sectors. One of the things we've been focused on the last 6 months has been the UK's civil hydrography programme, and this is updating chart data. We've completed surveys around Scotland, around the northeast of England, around the east coast of England, and that's, as I say, collecting bathymetric survey data. We've also completed a number of projects in the oil and gas sector, predominantly looking at pipelines and looking at the integrity of those subsea structures, and we've done that for multiple oil and gas companies.
It's really interesting. And looking ahead to 2030, what changes do you envisage for the ocean data sector?
Yeah, I think everybody's indicating a massive growth in the ocean economy. People such as the OECD would be predicting a doubling of the ocean economy to 3 trillion in the next decade. And we believe the foundation for that growth, be it aquaculture, offshore wind, oil and gas, leisure uses, it all needs to be underpinned by data. Data really is the foundation here. So we see that there's going to be a need for more data and more often to collect that data. And we believe unmanned systems can present a really useful way of collecting that.